So this is the part 2 for linear block code. So here the encoder circuit is you have to draw the encoder circuit for 7,4 block code. Generator matrix is given like this. So there are 7 columns and 4 rows. That means there are 7 code bits and 4 message bits. So for you have to make the generator matrix, you have to label it like this. So first column corresponds to C1, then C2, C3, C4, C5, C6, C7, and first row corresponds to M1, M2, M3, M4. So this is useful when you have to write the equations for different code bits. So how to write the equations for different code bits? So C1, for writing the equation for C1, you have to see where is 1. So 1 appears at M1 only, M1 row. So you have to write M1. C2, where is 1? 1 appears at second row, that is corresponds to M2. So write it M2. C3 at M3. C3 equal to M3. C4 equal to M4. Now C5, 1 appears 3 times in row M1, then row M2, then row M3. So you have to write M1 plus M2 plus M3, that is XOR. Plus means XOR or mod 2 operation. C6 is M2 plus M3 plus M4. C7 is M1 plus M2 plus M4. So after that, so this is also useful when they ask you to form the generator matrix from the equations given like this. So this is important for 2 questions. After that you have to draw the diagram. So for the diagram, you have to remember this structure. So in this structure, there are first there are 4. You have to draw the blocks for message bits. So M1, M2, M3, M4, and after that how many parity bits are there? 3 parity bits. So P1, P2, P3. So 3 parity bits. Because message bits are 4, so first these message bits appears here, C1 to C4. These message bits appears here, C1 to C4 for the code bits, and after that there are parity bits which are 3, that is C5, C6, C7. Okay. So input message comes first. So here it is M1, M2, M3, M4 appearing. So they are shifted in these blocks. After that there is a switch which is connected to this pole. Then it will take M1 first, then M2, then M3, then M4. That means C1, C2, C3, C4 appears here. After that for C5, C6, C7, this will be shifted here. Now what is the equation for C5? C5 equation is M1, M2, M3 XOR. So you have to take M1 plus XOR, M2 plus M3 and XOR it. That is P1 also, that is parity bit. C5, C6 is M2, M3, M4. M2 plus M3 plus M4, that is C6. What is C7? C7 is M1 plus M2 plus M4. M1 plus M2 plus M4, that is C7. So when this switch is at this pole, then you will get C5, then C6, then C7. So at the code bits are C1, C2, C3, C4. After that C5, C6, C7, or M1, M2, M3, M4. After that P1, P2, P3. So this is a systematic code. So let us do one practice example. So this is the generator matrix given. Now how many columns are there? 6. So the code bits are 6. How many message bits are there? 3. So message bits are 3. So you have to draw this structure now. First M1, M2, M3 input message till this only, and this also you can draw. So first the message bits will appear M1, M2, M3. So from this also C1 is M1, C2 is M2, C3 is M3. After that parity bit, C4 is M2, M3. So C4 is parity bit 1, M2, M3, M2, M3 XOR. After that C5, M1, M3, M1 plus here C5, M1 plus M3, that is P2. C6. C6 is M1 XOR M2 or plus. We are saying plus or XOR. M1 plus M2. C6 is P3, that is M1 plus M2. So after that, after taking the message bits out, which are nothing but first three code bits C1, C2, C3, this will shift here. Then it will take parity bits P1, P2, P3, which are nothing but C4, C5, C6. So code is like this, appears at this side, that is C1, C2, C3, C4, C5, C6, which is nothing but M1, M2, M3, P1, P2, P3. This is systematic because first message bits appears, after that parity bits. Now second type of question is this one. For systematic LBC, the three parity check bits equations are given and you have to construct generator matrix. So first you have to see, you have to decide for the number of columns and number of rows for the generator matrix. Number of columns are nothing but number of code bits, and number of messages are nothing but number of rows. So how many messages you see here, message bits you see here? So number of message bits are D1, D2, D3. That means here D1, D2, D1, D3. That means there are three message bits. So there are three rows to the generator matrix. Now first three bits, that is D1, D2, D3, nothing but C1, C2, C3. After that, these are parity bits. So message bits are 3 and parity bits are 3. That means code bits are 6. So number of columns are 6. You understood na? Number of message bits are 3 and number of parity bits are 3. 3 plus 3 is 6. So code bits are 6. That means number of columns are 6. So number of columns are 1, 2, 3, 4, 5, 6, and number of messages are 1, 2, 3, number of rows. So we have already seen that C1 corresponds to D1, so 1, C2 corresponds to D2, C3 corresponds to D3. So this is identity matrix of dimension 3 by 3. So from where it comes 3 by 3, number of message bits are 3, that's why 3 by 3. After that, for C4 they have given the equation D1, D2, D3. So 1, 1, 1. So in each row you have to write 1, 1, 1. For C5, in rows of D1 and D2 you have to write 1, 1. For C6, in the rows of D1, D3 you have to write 1, 1. Let us do this example. So first, how many message bits are there and how many parity bits are there? First we will see that. How many message bits are there? So you can see here that message bits are M1, then M2 is also there, M3 is also there, M4 is also there, M5 is not there. So there are 4 message bits. That means number of rows of the generator matrix are fixed, that are 4. How many parity bits are there? 3. That means 4 plus 3 is equal to 7. So number of columns are 7. That means number of code bits are 7 and number of message bits are 4. So number of message bits are rows and number of code bits are columns. Now number of C1, you know C1 is M1, C2 is M2, C3 is M3 and C4 is M4. So this is an identity matrix of dimension 4 by 4. Number of messages are 4. C5 is equal to M1, M2, M3. So 1, 1, 1. C6 is M2, M3, M4. So in the columns in the rows of M2, M3, M4 you have to write 1. For C6 column. For C7 column, in the rows of M1, M2, M4 you have to write 1. So 1, 1, 1. So this is the formation of generator matrix. So in part 3 we will see syndrome decoding. So with part 1, part 2 and part 3, linear block codes typical examples are covered, which are mostly asked, and if you understood these you can solve many such problems because there are only changes in these bits only. So where one appears, that changes, and if you know the logic you can solve that problem.